Hello and welcome to the relationship section of the National 5 video tutorials. Today we're going to talk about more complex straight lines, the ones with the form y minus b is equal to m times x minus a. So when you're dealing with a line that you have to use y minus b equals m times x minus a for, m stands for your gradient, which is y2 minus y1 over x2 minus x1, as it was before. And a and b stand for different parts of the same coordinate that has to be lying on the line. So in the case of the left-hand side line here, a is equal to 3 and b is equal to 5. What's important to remember is once you've got the formula in terms of y minus b equals m times x minus a, you then need to rearrange your answer so that it is put into the form y equals mx plus c, as was explained in the previous video. Okay, so let's attempt a question like this. Our two coordinates here are minus 5, minus 2, and 7, 4. Okay, that's what we'll be using to figure out our gradient. So in this case, m is equal to y2 minus y1 over x2 minus x1. So we're doing 4 take away negative 2 divided by 7 take away negative 5. 4 subtract negative 2 is just the same as 4 plus 2, which is 6. And 7 subtract negative 5 is the same as 7 add on 5, which is 12. Both of those numbers divide by 6, so our final gradient is 1 over 2. Okay, so we can write out our formula in terms of y minus b equals m times x minus a. Y minus, we're going to use the y coordinate of one of our coordinates. So I'm going to go for this coordinate here, 7, 4. So we'll do y minus 4 is equal to 1/2 of x minus 7. Okay, I've used the 4 and the 7 from the coordinate 7, 4. The next line of working here is I'm going to multiply both sides of the formula by 2. So I get 2y minus 8 is equal to x minus 7. This is me starting the process of putting the formula back into the terms of y equals mx plus c. If I add on an 8 to both sides, I get that 2y is equal to x plus on 1. And then if I divide through by 2, I get my final answer of y is equal to 1 over 2x plus on 1 over 2. Now I have the formula in terms of y equals m, my gradient is 1/2, x plus on c, and my y-intercept is 1/2 as well. Okay, so that's my final answer. This question is much the same. We're dealing with a negative gradient this time, so that might prove a little bit more difficult for some people. So let's have a go at this. I'm going to use the two coordinates that are mentioned there in the diagram to find my gradient. So m is equal to 2 minus 6, that's my y2 minus y1, over 7 subtract negative 5. 2 take away 6 is minus 4. 7 subtract minus 5 is like 7 add 5, which is 12. So because those both divide by 4, my final answer there is negative 1 over 3. I'm going to then put it into the form y minus b equals m times x minus a. So I've got y take away, I'm going to use the coordinate 7, 2 over here to substitute into my formula. So it's y minus 2 is equal to negative 1/3 of x minus 7. If I multiply both sides of the equation by 3, I'll get 3y's minus 6 is equal to negative x. Now, it says negative in the bracket, but because I'm multiplying through by a negative, that's going to change to a positive 7. Final part of this, add on 6 on both sides. I get 3y is equal to negative x plus on 13. And if I divide by 3 on both sides, I get that y is equal to negative 1/3 x plus 13 over 3. Again, I've got my formula in the terms of y equals m, which is negative a third, x plus on c, which is 13 over 3. So that's my final answer. Here are two examples for you to have a go at. Make sure you put your final answers into the form y equals mx plus c, but for both of these you're going to have to use the equation y minus b equals m times x minus a. Okay, pause the video now because I'll reveal the answers in just one moment. Okay, so the solution for line number 1, your gradient is 7 over 9, and your final answer should be y is equal to 7/9 of x plus on 31 over 9. And for the second line, you should have that the gradient is negative a half, and y is equal to negative a half x plus on 3 over 2. Remember that these lines have been rearranged to be in the form y equals mx plus c, so if you didn't get these answers, maybe there's a problem with your rearranging of equations. Make sure you ask a teacher if you're finding that difficult. Sometimes the SQA gives you this type of question without a diagram, where you're given just the two coordinates and you have to find the equation of the line. This isn't too much trouble. Again, we're going to use m is equal to y2 minus y1 over x2 minus x1 to start. So I'll do 6 take away 2 over 11 subtract negative 5. 6 take away 2 is 4. 11 subtract negative 5 is 16. Both divide by 4, so my gradient is 1/4. To put this into the equation now, I'm going to use the second coordinate as my a and my b, so my a is going to be 11, my b is going to be 6. So we get y minus 6 is equal to 1/4 of x take 11. Alright, if I multiply both sides by 4, I get 4y take away 24 is equal to x take away 11. Add 24 onto both sides, I get 4y is equal to x plus on 13. And then my final answer, to get 1y on its own, I'm going to divide by 4, and I get y is equal to 1/4 of x plus 13 divided by 4. That's a terrible 13. But hopefully you understand that there is 13, oh my goodness. Okay, so I've got the equation in the form y equals m, 1/4, x plus on c, so c is 13 over 4. And that's my final answer. Okay, so here's a couple of examples for you to try and improve your skills with. Make sure you put your final answers again in the form y equals mx plus c, and pause the video now because I'll be revealing the answers in just one moment. Okay, so the answer for question number 1, your gradient is 3 over 5, and your final answer should be y equals 3 over 5x plus on 13 over 5. And for the second one, you should get a gradient of negative 2 over 3, and your final answer should be y equals negative 2 over 3x plus on 5 over 3. Finally, if you'd like to try your hand at an exam style question on straight lines that are using y minus b equals m times x minus a, then have a look at these past paper questions. Remember, they can all be downloaded for free from the SQA website. Keep studying hard, and thanks for watching.